Our learning goals today are I can define the midpoint of a segment in a segment bisector and use the definition to solve for unknown lengths with justification. I can find the midpoint of a segment using a number line or coordinate plane or when given the coordinates of endpoints of a segment. So, we need to find each length. So recall, what terms can we be used from previous lessons? So we're going to find the length of AB. So from A to B, that's 1, 2, 3, 4. B to C is 3. C to D is 3. And B to D is 1, 2, 3, 4, 5, 6. So what do you notice about the measures? Well, you should notice a couple things. One thing is that BC is equal to CD. Those two segments are actually congruent. BC is congruent to CD. Another thing that we should notice is that BC plus CD is equal to BD. That's our segment addition postulate. What would be a good name for point C with respect to CD? So we know that C is right in the middle. So we could use between. We learned that from last week. Or middle, center. But the one thing I'm trying to get you to go for is actually the midpoint. So, midpoint of a segment. The midpoint of a segment is the point that divides a segment into two congruent segments. So, in this picture, the midpoint of AB is point M. The point is equidistant from each endpoint. So AM is equal to BM. It's right in the middle. It's equidistant. A segment bisector is a line, segment, or ray, or plane that intersects a segment at its midpoint. So B is the midpoint, and line L goes through that midpoint. And so L is a segment bisector of segment AC. Using a midpoint or segment bisector to solve. So first thing we're going to do is we're going to be drawing this picture. So DE bisects AB at C. So here's AB. And at point C, we have this, bisector. I'm just going to do endpoints because it didn't say it was a line. D, E, and at point C. We know that AC is 8x minus 23, and CB is 3x plus 22. We want to find x. Because we know that DE is a bisector, we know that these two segments are congruent. So we know that 8x minus 23 is equal to 3x plus 22. So we're going to subtract 3x from both sides. So we get 5x minus 23 equals 22. Add 23 to both sides. So 5x equals 45. Divide by 5, x equals 9. Okay, so we're going to be solving using a midpoint with justification. So S is the midpoint of RT. What are RS, ST, and RT? Justify each step. So because it's a midpoint, we know that these two segments are congruent. So we know that RS is congruent to TS. And that is from midpoint. Okay. And then from there we know that RS is equal to TS. That is from congruent segments. Okay, so from there we can plug in, so 7x minus 3 equals 3x plus 1. That is substitution. So now we're going to minus 3x from both sides. We have 4x minus 3 equals 1. So that was our subtraction property of equality. Now we are going to add 3 to both sides. So we get 4x equals 4. That was our addition property of equality. Now we're going to divide by 4. So we get that x equals 1. And that was our division property of equality. So now, our main thing was we want to find RS, ST, and RT. So RS, that's 7 times 1 minus 3. So we get 7 minus 3, which is 4. ST, which is 3 times 1 plus 1, which is also 4. And RT, well, that's just 4 plus 4. So that's 8. Is that reasonable? Yes. Checks out. Okay, so along with midpoints, we have a midpoint formula on a number line. So the coordinate of the midpoint is the average or the mean of the coordinates of the endpoints. So our formula is x1 plus x2 divided by 2. Okay? So we want to find the midpoint of each segment using our formula. So PQ, that's x1. Our P is x1, Q is x2. So Q is actually at 6. So we have negative 16 plus 6, all divided by 2. Negative 16 plus 6 is negative 10 divided by 2. Negative 10 divided by 2 is negative 5. So the midpoint of PQ would be at negative 5. So right here would be the midpoint. Okay, midpoint of RS. So R would be our x1, S is x2, negative 4 plus 12 over 2. Negative 4 plus 12 is 8. 8 over 2 is 4. So right here, 4 would be the midpoint of RS. Okay, so that was just on a number line. Now the formula on a coordinate plane. So formula is about the same. The only thing we have to do extra is figure out that y coordinate. Okay? So finding a midpoint on a coordinate plane. So let's just go ahead and use our formula. So A is x1, y1, B is x2, y2. So we have 2 plus 6 all divided by 2. That's for our x-coordinate. And 1 plus 6 divided by 2 is for our y-coordinate. So we get 8 divided by 2, and then 7 divided by 2. So 8 divided by 2 is 4. 7 divided by 2 is 3.5, so that is our midpoint. So at 1, 2, 3, 4, 3.5. Okay, next picture. So let's get our x1, y1, x2, y2. So our x-coordinate, -5 plus, or -2 plus 5 over 2. Y-coordinate is 0 plus -4 over 2. So we get 3 divided by 2, and then we have -4 divided by 2. Divide them both by 2, so our midpoint is 1.5, -2. So 1.5, -2 would be right here on our graph, and that's the middle. That's our midpoint. Okay, so more midpoint practice, not on a graph. Again, let's just go ahead. I like to label our points. So x1, y1, x2, y2. Do our x's first, so -2 plus 4 divided by 2. 5 minus 7 divided by 2. So we get 2 over 2 for our x, -2 over 2 for our y. Divide that out, so our midpoint is at 1, -1. Okay, try it again. x1 and y1, x2, y2. So for our x's, we have -8 minus 3 over 2. For our y's, we have -11 minus 3 over 2. -8 minus 3 is -13 over 2. -11 minus 3 is -14 over 2. Divide that out. Our midpoint is at -6.5, -7. Okay, M is the midpoint of AB. Find the coordinates of B. So this is if you are given the midpoint. Oops. We're given the midpoint and an endpoint. So on your picture, it looks like this. We have A, we have B, and we have M. We don't know what B is. B is our question mark point. We don't know what it is. So in this case, this is x1, y1, and this is xm, ym, not x2 or y2, xm, m for midpoint. So in our formula, B is x2, y2. So we have 4 plus x2 over 2 and 3 plus y2 over 2, and that equals -2, 1. So what I like to do is I like to take the x's and set them equal. So 4 plus x2 over 2 equals -2. First thing we gotta do is double everything. So take everything times both sides by 2. So we get 4 plus x2, because these 2's cancel each other out, equal to -4. Okay, let me just resize this. Okay. So now we're going to subtract 4 on both sides. X2 is equal to negative 8. So that's our x coordinate. Now our y coordinate. We have 3 plus y2 over 2 equal to 1. Again, get rid of that 2 on the bottom, as you have to times both sides by 2. So the 2 you multiply and the 2 that's dividing cancel. So we're left with 3 plus y2. And on the other side we have 2 times 1, so that's just 2. Now we're going to subtract 3 from both sides. We get y2 is equal to negative 1. So our b is negative 8, negative 1. I know that might have went a little fast. Let's try again. Okay. I'm going to show you a different method. This method works a lot, so if you don't like using the algebraic way, we can do it this way. So remember, a is at 0, negative 1. M is at negative 9, 16. So let's look at our x's. So to get from 0 to negative 9, so this is for our x's. So to get from 0 to negative 9, we subtract 9. That's halfway. So to get to b, we have to do another minus 9. So b, it would be at negative 18. Now for our y's, we're at negative 1 and we're going to 16. So what we actually did to get from negative 1 to 16, we added 17. So what we have to do to get to b is add another 17. So 16 plus 17 is 33. So b is actually at the point negative 18, 33. So there's the two different ways. So you can do it algebraically using the formula, or you can do it visually using your picture. So just think. So to get from 0 to 9, we had to subtract 9. So we get, and that's halfway, so we have to do another 9 to get to b. I don't know. I like to show both ways because some kids just learn better visually. So our summary, look over the learning goals at the beginning. What do you know at this point in your learning? What are you unsure of at this point in your learning? What type of questions do you have? So quick fill this out, and then you can get started on your homework.